I pulled out a few headlines this week just to show you what these people are publishing. The question is, how is it that these people are allowed to publish this garbage, this nonsense, this poppycock has nothing to do with science, let alone with physics. And they're allowed to publish this stuff. There are peer reviewers who approve these things for publishing. And these are the version given to the public, but they come out of what is called the scientific literature, meaning that the guy was peer-reviewed and he was allowed to publish in some physics magazine run by the mathematicians who call themselves physicists. And then these guys translate it for the public like saying, oh, look what the scientists discovered. And here you see some of the headlines. They're all laughable, okay? What astronomers just discovered between galaxies changes everything. Oh yeah, it changes everything. I like that. Tiny primordial black holes created in the Big Bang may have rapidly grown to supermassive sizes. Yeah, sure. Black holes, what are those? Singularities, what are those? Just infinite whatever. Infinity, things falling forever into this little hole, which is not a hole, and etc., etc. A ghost particle flew through Earth. It might have come from dark matter. I mean, these are ridiculous notions. They should never have made it to science, let alone to the public. They're written by crackpots. Scientists produce a particle of light that simultaneously accesses 37 different dimensions. Okay, so it depends on how many beers they had, you know. In this case, I guess it's 37. Okay, space.com. Roman Space Telescope will use a century-old idea from Einstein to probe the nature of mysterious dark matter. What is dark matter? Well, it's all that stuff that they had to sprinkle on the outside of a galaxy to explain why the stars on the outside of a galaxy travel just as fast or faster than the ones on the inside, which is, in their mind, irrational. So the only way they can explain it is by throwing kilograms out there, and they say, oh, these kilograms are invisible. No kidding. I mean, kilograms is a concept, right? So yeah, when you deal with kilograms, you're going to end up with nonsense. Scientists claim they just discovered an ultramassive black hole heavier than any other we found. All they talk about is the biggest black hole, the smallest black hole, the oldest black hole, the youngest one, the farthest one, the closest one, you know. Is this science? Is this what we're going to have the rest of eternity? Just black holes at different sizes? Another one, astronomers suggest that entire stars are being obscured by giant lampshades of dark matter. Oh man, all that dark stuff. Black or dark. I think these people are racist. That's what I really think, you know. New study rejects Big Bang theory. It says universe grew via cosmic energy bursts. Yeah, except that energy is cannot burst because it's a concept. Okay, energy is like what Dick Feynman said. He says we have no idea what energy is, and everybody uses the word energy, but nobody knows what it is. And yeah, is it a physical object? Can you transfer it? Show me a picture. I want to see the picture of energy. Okay, before you transfer it. Okay. Okay, so here's a couple that are funny because they come out of such groups as the ones you just saw. One says, what shape is the universe? Good question. What shape is the universe if the universe is a physical object, right? 13 billion years ago in the beginning, right? It starts like the Bible. In the beginning, everything existed in one chunk of matter. Okay, not all so-called physicists, mathematical physicists agree with that. They have different versions, but this guy believes it's one chunk of matter. The Big Bang created the vast nothingness we have today, so we have a Big Bang creating nothing. I do that every day. Create nothing every day. Big Bang did the same thing 14 billion years ago. Okay. Most astrophysicists believe the cosmos is flat. Okay, there you see the flat zero curvature universe. That's our universe there, folks. It's a flat board. Okay? A 2D sketch of the 4D phenomenon is impossible to draw. No kidding. I mean, you know, how do you illustrate a 4D object, let alone a 4D phenomenon happening, you know, occurrence? Okay, space bends around anything with mass the way a trampoline sags under a drop ball. Okay, they have the ball on canvas on fishnet notion there, right? Black holes send out ripples of gravitational waves like pebbles in a cosmic pond, okay? And gaps between galaxies stretch and contort over time. So they have these notions that you have all these galaxies far away from each other on a fishnet, you know, and they weigh down the fishnet locally, I guess, and that local bending travels all the way to the other galaxy, and that's why the galaxies attract each other. But as you can see, because they're all unsynchronized, I don't know how one galaxy pulls on another galaxy from so far away, because galaxies are separated by quite a bit. And so if a galaxy bends space-time, you know, weighs it down using Newtonian force, right? Weighs it down, how does it pull on another little boat, which is, or worse, it's really, what is it? What are these things called? I forget the name. But imagine a rowboat far away. You know, why would it, if this ocean is malleable, how does one boat pull on another boat? That's, I was thinking of a buoy. That's what it was. You know, you have this buoy just locally, right? It's bobbing up and down here. How does it affect this buoy that's 100 miles away? And so that's what they've never explained. They just say, oh, it bends space-time and that's gravity. So yeah, this notion is what they spread to the public, which is total garbage. It has nothing to do with reality or with what Father Universe runs out there every day. Here you have another one. Is the universe really infinite? Oh, he's going to explain. An astrophysicist is going to explain. There's physically absolutely zero way we will ever know how large the universe is. Yeah, no kidding. This is not a question of knowledge. It's a question of making an assumption so that we can follow your theory. So you have a theory in which you say that the universe is infinite or finite, whichever one you choose, we don't care. Then you have to illustrate if it's finite. And if it's infinite, you got to say, well, then it's not a physical object because no object is infinite. In other words, one of the two, or it has something on the outskirts that gives it shape, that serves as a backdrop, or it's infinite, in which case it's not a physical object, because you're not saying that it's an object is infinite. What you're saying is, if I travel, you know, all the way to the edge of the universe, I'll never get there because there is no edge to the universe. And what you're saying is you're using an adjective called infinite to qualify what should be qualified with an adverb, meaning incessant. You're talking about incessant motion, not about, you know, infinite universe, infinite object. Space is actually expanding, it says. Okay, so I thought space was a concept, nothing, you know, that which doesn't have shape. That's our definition. And these people say that this thing that doesn't have shape, this word that doesn't have shape, this nothingness is expanding. Great. So see, whenever they need space as a physical object, they talk about expansion. Then that same guy goes to another conference that says, oh, by the way, you know, space is not a physical object. It's nothing. It's a vacuum. If you remove all objects from it, you have absolutely nothing. You have vacuum. And so what is that? I mean, are these people saying that this nothingness expands? Again, it makes no sense because they're treating space as a balloon, as a physical object, as a container, and they're saying this container gets bigger every day. So what's on the outside of the container? And that's when they say, well, that's an irrational question. You're not allowed to ask that question. Okay? It says the nothingness of space doesn't really abide by the laws for matter and physical things. So is space a physical thing? How can it expand if it doesn't follow the laws of matter and physical things? We have a contradiction right there and then. It says the universe shape is what? Flat. Flat doesn't mean what? What does it mean? It means traveling forward without changing direction. In the universe, we'll never get back to where you started. No, that's not what flat means. Flat means that if your floor is flat, what you're really saying, ideally, right, is that it's there's no curvature to it, meaning that it's thin as a pancake, but thinner than that. It's you can't see it from the side. That's what flatness is. Flatness is what you have in plane geometry. That's flat, ideally, right? So flat only belongs to the world of two-dimensional objects, such as squares and so on. And you can't bring the word flat, because what these people again are doing is talking about flat, which is an adjective, and they're explaining flatness with an adverb. They're saying you're talking about motion, you're talking about traveling, changing directions, etc., right? And so they're explaining flatness with motion, with a dynamic explanation, dynamic objects or things that are moving. You don't explain a static concept such as flat with a dynamic one. And says the universe is most probably a four-dimensional sheet of paper. Yeah, no wonder they can't illustrate it, because they say, I try to illustrate it on my piece of paper, these 4 dimensions, and somehow I can't put it in there, I can't fit it in there. No kidding. Okay, so last article here, which is funny too, because you've heard of the 4 forces. I think I call them the four horses of the apocalypse, because they invented all these forces, right? And they say there's push, pull, and maybe and perhaps. Okay, so here they have the 5th force of nature may have been discovered inside atoms. Oh my God, we have a 5th force. Forget about 4. Now we got 1 more. Every action in physics is governed by what? Some kind of push or pull. We're done. That's it. That's the only types of physical contact we can imagine. You either push or you pull. Okay, those are the forces. In fact, I always tell people that when you have tension, it's not a force. Okay, because tension means nobody wins the tug of war. Push, pull are forces because they are things in motion. Tension is there's no motion. Okay, the best notion of tension is a a dumbbell. You have the 2 weights and a dumbbell between them. Does the dumbbell move in one direction or the other towards one of the balls? Absolutely not. It's always fixed. That's tension. Okay, that's the analogy for tension. But it says, as far as we know, these all fall into 1 or just 4 categories: electromagnetism, gravity, and 2 kinds of nuclear forces. What do you mean 2 kinds of nuclear force? I thought the weak force, there you said, is a push force, and strong, the gluons, they're a pull force. They bring quarks together, right? So we still have 2 forces, push and pull. Where do they get these 4 forces, let alone the 5th one? Okay, so yeah, may the force go with you. Forget about forces. They talk about forces instead of talking about physical objects that mediate the force, right? Okay, so here we have the standard model. Okay, we've all seen that. Okay, it looks more or less like that. Some of you know it by heart, so I'm not going to dwell too much on that. And they weren't content with this. They said, first of all, they invented all these stupid particles that don't even belong there. Some are force carriers, meaning they're verbs. And the other ones are the ones that build the atoms, the matter. And so those are nouns. The ones on the top, the green ones there, are nouns. The ones on the bottom, the bluish ones, violet ones, those are verbs, because those are forces. Okay, so keep that in mind. Okay, this is important, because people don't realize that these people are comparing apples and oranges, or worse, nouns and verbs. Okay, so they were not content with this. They had to invent supersymmetric particles. Now we have other types of particles that were brought in, because they had to give these people something to do, the new generation. They say, well, what do we invent now? Everything's been invented. And someone says, oh, I got it. Why don't we say that they have different spins? So the bosons, the bosons, they have different spins, and they give them a different name. And the fermions, they have a different spin. They give them a different name, okay? And so here you have the chart, so you get an idea, okay? Supersymmetric particle, SUSY, right? Good old SUSY there. Predicts. They always predict that. No, in science we don't predict. We make an assumption. These people call it a prediction. It's not a prediction, it's an assumption. You're making an assumption in order to explain your theory, or whatever theory is founded upon that assumption. Every particle has a corresponding superpartner with a difference of half spin. That's an assumption. That's not a prediction. Extends the standard model of particle physics. a theoretical framework. Again, it's an assumption and it's not a theoretical framework. Or you could say an assumption is a theoretical framework, but these people are talking about theory, which is an explanation, and assumption is a hypothesis. Hypothesis is only assumptions that you need to make in order to give a physical interpretation to your theory. Postulates a symmetry between bosons and fermions. Okay, the fermions, electron quarks, they have half spin, and the bosons have photons and the W's, the weak forces, right? Integer spin. And there you see it. The red ones correspond to the red ones. They had to create these same letters, but they put a little sign on top so that you would recognize them as a different type of particle. And they did the same thing with the fermions, where, you know, the green ones there that you can see on the right, they have the same letters, but they had to put a little line over them. Okay, so that's what they did. And for this, they win Nobel Prizes, I guess. Not yet, but they will if they happen to discover one, you know. So don't hold your breath. Okay. Okay, so what do we have? What is SUSY? Supersymmetric particles. Here we'll have a super duper British guy, I think, and he's going to explain to you what it is. So you don't take it from me, you take it from the horse's mouth. Here it is. Here it goes. Listen carefully.
Supersymmetry postulates that the standard model is incomplete. There are other particles we've never seen before. Each standard particle would have a super partner in the other category, such that there would be a new boson for each fermion and a new fermion for each boson. The fermions, electron, quarks, neutrinos, would each have a boson partner, selectrons, quarks, neutrinos, while bosons, photon, gluon, Z, W, Higgs, would each have a fermion partner, photino, gluino, xeno, wino, Higgsino. Supersymmetry is the hypothetical symmetry between particles of matter and interaction.
So again, what these people are doing is confusing nouns with verbs. Some of them are force carriers. That's what they call them. In other words, they're the interaction itself. And they had to create a particle that serves as a mediator for the force for the interaction. So this is as irrational as it gets. You have a ball that represents motion. That's what it is. Those are the bosons. I'm sorry, it was the bosons. I call them bosons. The people who invented them. And then you have the fermions, and they are the ones that construct matter. Okay? So those are nouns, or treat as nouns. That's the notion that they're introducing here. They say these are nouns. These are things that build matter, which are things, you know, nouns. And these other guys are the mediators of transactions, and we call them verbs. You know, they're force carriers, and they represent them with a ball. So now they created the supersymmetric force carriers, supersymmetric verbs. That's what we have. Okay, so yeah, it's a bunch of nonsense what comes out of the establishment. But they're looking for them. They say, oh, hopefully one day we'll discover some of these neutrinos or snowinos. The winos, okay? And so we have here, what's the difference between them? You see that it's the spin. The ones in red correspond or are opposite the other ones, whereas you have the squark and the leptons, and they are zero spin, whereas the other guys are half spin. So some are integers and some are not. And for the green ones, you see the same thing. You have the halves on the right-hand side, the winos, especially the binos. And on the left, you have the ones, okay? So all they did was change the spin. They say, hey, I know, I can get an O for this. I'll just say that they have different spins, and with that, I've got a new category of particles. That's what they did. That's it. And you say, well, two things, you know. First of all, why did they have to create this nonsense? And second, you know, what is this spin thingy that is different between them? Does it mean that like a top, it twirls around and the other guy spins in the opposite direction or upside down, or what is this? And so here's the super duper definition of spin so that you can take it to the bank with you today. Here it is, okay? Twirling top metaphor for electron spin. Well, electrons aren't thought to spin they're frequently depicted as if they do. Yeah, in fact, you can see the depiction there, the illustration, and it shows you that this roundish arrow that goes around, and they're talking about spin, how you would spin a top. But that's what they later on deny and say, well, it's not spin. Spin is not spin like a top. We just illustrate it that way to confuse you. Okay, so why can't they illustrate it? Well, here it is. Electron spin theory describes the electron as a quantum particle instead of a simple sphere. So not only we have the electron, which is not a sphere either. Okay, they don't know what an electron is, what it looks like. They've never seen one. Okay, even though the Swedes filmed one, right, a few years ago. They filmed one. They never got a Nobel Prize. And you say, well, why didn't they? I mean, filming an electron, that would have been, groundbreaking. And the question is, why did they ever allow that to be published at all? Why did it reach the public from these cranks from Sweden? Okay. Anyway, it says physicists have not yet developed a visualization of physical reality that underlies spin. Yeah, they have no clue what spin is. They just used a word and they illustrated a spin, but then they say, oh, we have no idea what spin is. But they are able to describe, not explain, right? Describe spin mathematically and predict its behavior in lab experiments. What they are predicting, we are again predicting, astrology, however, is the magnetic properties of quantum particles, not their rotational motion. The key to understanding spin is to realize that whatever it really is, its physical manifestation is magnetism. Okay, so they're talking about magnets, and the question is, give me a second here. Thought I'd wake myself up. Okay, so what is it? They have no idea what spin is. And so why did they need this stuff? Why did they have to create it? I mean, just to create more particles? Was it just, hey, we have nothing to do, why don't we create more particles? We'll just make them differ by spin. Okay, that's an idea to keep making money and creating a future for yourself, job security, right? But here it is. This is the reason they had to create it. They said, standard model can't explain relatively small mass of the Higgs. Okay, the Higgs boson, that's the one that gives mass to particles, however you want to interpret that. This ocean through which particles have to travel, for some particles is more difficult and therefore they have more mass, that's the idea, compared to other particles. SUSY, right, good little SUSY, offers a potential solution by introducing super partners that can cancel out the large contributions to the Higgs mass. Okay, that's why they had to create it. SUSY unifies quantum forces, electromagnetic, etc., right, at very high energies. Okay, so again, high mass, high energies, energy is mass, according to Einstein's equation, right? Light as supersymmetric particles, LSP, predicted to be stable and weakly interacting. Okay, and so SUSY is also a dark matter candidate. So we kill two birds with one stone with the SUSYs. We have, on the one hand, we can explain the Higgs, right? And on the other hand, we can explain dark matter. So it was a dual purpose kind of thing. But the problem that they encounter is, to this day, they have not discovered a single one of these particles. So they're very frustrated. They're discouraged because they can't find them. But I suspect that soon, they're very close to discovering at least one of these particles. And here it is, okay? And it's the wino. So yeah, I think pretty soon they'll discover the wino over there at the LHC.